Let's take a look at a couple domain problems with logarithms. So the first thing we need to do here is we kind of got to think about when is the domain defined or where are there breaks in the continuity in both the numerator and the denominator. So first of all, you can't have a negative number inside of here, right? Whatever's inside the parentheses of this logarithm has to be positive. So the first thing I'm going to do here is say 3x plus 8 has to be greater than 0. So that means 3x is greater than negative 8, and then that means that x has to be greater than negative 8 over 3. Not greater than or equal to, because we also can't have a 0 inside there. So x has to be greater than negative 8 over 3. All right, we're going to leave that for a second and come back to it. And then we also know that you can't have a 0 in the denominator, because that's going to create a vertical asymptote. So we're going to say this cannot be equal to 0. And then we're just going to solve this quadratic. And we're going to get two solutions here. So what does that mean? Well, x cannot be equal to 4, and x cannot be equal to 1. Okay, so now I'm going to go ahead and my suggestion here is to always set up a number line, because this is going to help you organize your information. So if I set up a number line here, right, I'm going to have, first of all, I'm going to have that value of negative 8 over 3. So I'm going to have that. I'm going to put an open circle here because it's not going to include that number. And then I'm also going to have two other points. I'm going to have at positive 1 and then positive 4. So that means that the function is not defined, or there's a break in the domain at 1 and 4. And remember, this number has to be greater than negative 8 over 3. So what does that do? Well, that cuts out everything over here. So now you're just left with this area with breaks at 1 and 4. And now I can record my final answer for the domain. So the domain of this function is going to be negative 8 over 3 to 1. Then again from 1 to 4, putting that union signifying the break in the domain at 1 and 4. And then it goes on to infinity. So this would be my final answer for the domain on this first problem. Okay, let's look at one more with a logarithm that's a little more complicated, but still very doable. Okay, so again, we need to figure out where is the function defined, both in the numerator and denominator. Well, let's start with the numerator. So if we look at the numerator here, 49 minus x squared has to be greater than or equal to 0. Remember, with the square root, we can have a 0. Okay, so what am I going to do here? Well, if you think about it, right, like if this number is less than negative 7 or it's greater than 7, well, we have a negative number in here, right? Like, for example, if I put in 8, I'm going to get 49 minus 64. That's not going to work. The function's not going to be defined there, right? So really, just think about it, from a numerical standpoint, you're really saying that from negative 7 to 7 are the only times when the function's defined. Now, if you want to solve it algebraically, I would move the 49 over to the other side. We're going to divide by a negative, which is going to change. It's going to flip the inequality. Remember, when you divide by a negative 1, or divide by any negative, or multiply by a negative, you have to flip the inequality. And now you get two answers. You get that x has to be less than or equal to 7, and x has to be greater than or equal to negative 7. Again, thinking about the fact that you have a finite region where this function is defined. Okay, now let's deal with the denominator, because here's where it gets a little interesting. So we know that logarithms are only defined, even when it's natural log, doesn't matter, it's just different base. The base is z. X plus 3 has to be greater than 0, right? So that means x has to be greater than negative 3. Now the part that a lot of people miss is that we also cannot have a function that's equal to 0, right? Because in the denominator, because that's going to give us a vertical asymptote. So we need to solve this. Now remember, natural log means it really has a base of e. So we're going to convert this to exponential form. So I'm going to take that e over here, and I'm going to say x plus 3 cannot be equal to e to the 0. Well, what is any number to the 0 power is just 1. So we know that x plus 3 cannot be equal to 1. So x cannot be equal to negative 2. Okay, now notice we have really like 1, 2, 3, 4 points of interest here, right? 4 values that we got to set up. So this is where the number line really comes in handy. Okay, so I'm going to set up my number line. And I'm going to say, all right, well, -7, it has to be greater than or equal to that. So I'll go ahead and color in that dot. Then I'm going to say it also has to be less than or equal to 7. So I'm going to color in that dot. Okay, and automatically that means this region before and after those numbers, well, in this case before it and in this case after it, is not defined. We're only looking at from -7 to 7, but we have other things happening too. So here I'm going to say, well, x has to be greater than -3. Well, if that's true, then this region is also gone, right? And then our final one here is that x cannot be equal to -2. Okay, so I'm going to put a -2 here. And now I have just this little region where the function will be defined. And if you graph this, you would be able to see it. But let's write our final answer. So we're not going to include -3 because remember, logarithms cannot be equal to 0 inside the parentheses. They have to be greater than 0. We're going to have a break at -2. And then the function will be defined from -2 to 7. And we're going to include the 7 because 7 is okay if the function actually equals 0 in the numerator, because then the function is just equal to 0. So this is going to be our final answer here for our domain, and we're done with this one.